Welcome back everyone, my name is Pedram and this is where we do advanced time series analysis, deep forecasting. Okay, this is the last part 4 of Module 1, Demystifying time series data and modeling. Okay, in the past 3 lecture videos, we covered time series basics starting from very high level definitions. What is a sequence data? What are time series tasks? And we also discussed some fundamental concepts in time series like time series decomposition, ACF plot, and stationarity. In part 2, we explored different forecasting strategies. We said, okay, this is the first step in performing a time series task. What is your forecasting horizon? Are you doing one step ahead or multi-step ahead? And are we doing univariate modeling or multivariate? What are the benchmarks, right? Because after all, if your model cannot beat a simple benchmark, then we are wasting time. Then finally, in part 3, we explored different ways of modeling and discussed the pros and cons of either approaches, like a classical econometrics model, machine learning, and deep learning. Now, this is part 4. We want to see if we can beat the WallStreet, right? So we need to pay attention that coming up with a time series model that can outperform the naive forecaster in stock is one thing, and trading a winning strategy on top of that model is another thing, right? So here we are focusing on the first question. Can we make a model that can outperform naive forecaster? Is that model univariate or multivariate? And let's say we found that model, then what, right? So without further ado, let's jump into part 4. So module 1, part 4, can we beat the WallStreet? All right, let's look at some examples from stock market. So these are the big companies in US, including Apple. Let me see. Yeah, Apple, Amazon, Meta, Google, Microsoft, Nvidia, Tesla, S&P 500 index, Bitcoin, gold, US oil, and silver. So what do you see? Do you see any pattern, or you think that these price movements are completely random? Because it's going to make a big difference. If there's a pattern, maybe we can predict them. But if it is pure random, there's no way to predict them by simply looking at the historical data, right? So indeed, if there's a little bit of random movements in these time series, it's going to be extremely hard to forecast them into the future and make forecasts into the long horizons, right? So that's one thing. Another thing is that, okay, let's say the stock price is predictable. For now, we can assume that. Let's say stock price is predictable and you want to forecast it into the future. So you try hard and come up with a model. Then what is your benchmark, right? So when it comes to stock price, we need to clearly define a fair benchmark. How do you know that your model is doing a good job or not, right? So, and obviously, for example, what is not a good benchmark? An average, I can tell, is not a good benchmark, right? So for example, I don't know, let's look at Microsoft and we say, hey, what is the average? Historical average is something around here. And obviously this is not going to be a good benchmark because whatever model you have, if you do random, I don't know, whatever random model you use, it's going to clearly outperform the average, the total average, right? So we're going to say that, okay, average is not a fair benchmark. You want to come up with a benchmark that is, namely fair, right? So in order to answer this question, what is a fair benchmark when it comes to stock prices, we need to start by thinking about, is this stock price random walk or are there some patterns? Okay, so is a stock price random walk or not? What is a random walk process? What do we mean by that? Later on, we're going to show the formulas and officially define it, but for now, as the name suggests, a random walk process is a sequence of steps taken in a random direction, with each step being independent of the others, right? So look at this drunk guy. Each step he takes is completely random. He might move left, right, forward, or backward, wherever he is. So for example, if he's here, he can go up, down, left, right, and etc., right? And since he has no memory of his previous steps and no directions, his path is unpredictable and aimless. So the question is the stock price like this? Is it a random walk process? What are the arguments for this claim, right? So here are the main ones. The first one is efficient market hypothesis. So efficient market hypothesis suggests that the stock price rapidly reflects all the publicly available information. So new information arrives randomly, leading to unpredictable price changes that resemble a random walk. So this is the first argument for random walk. The second one is basically empirical evidence. What does the empirical evidence suggest? So basically, statistical tests typically fail to reject the random walk hypothesis. So if you assume that the stock market is random walk, typically statistical tests, whatever model you have, it fails to reject that hypothesis. So especially for short-term movements, many forecasting models struggle to consistently, and the key term is consistently outperform naive benchmark. So what is a naive benchmark? Remember, for example, whatever the close price today is, we're going to use it for the prediction for tomorrow. So the fact that historically many models have not been able to consistently outperform that naive benchmark, we're going to say, okay, this is a fact that maybe the stock price is random walk. Another fact is basically unpredictable events. Markets in general are driven by news, economic shifts, geopolitical events, and many of these things are inherently unpredictable and random. So these three are the arguments for random walk, right? So we say that, okay, stock price is random walk, and then because of these number 1, 2, and 3. But you might say that, wait a second, what about those patterns that we see in stock market, right? So what are the arguments against random walk? So let's consider those ones. Now, what are the arguments against pure random walk? So is the stock price not a random walk process, right? So basically, here's this Apple stock price. And the idea is that we see some predictability and patterns in the data, right? It's hard to deny that. First, look at this one. So we say, if this is completely random, so why the price is reacting to this, let's say, resistance line, right? Or why is it reacting to this support line? So why the price came down, you were expecting to go further down, but especially when it hit here, it went back up, right? And this is exactly where you were expecting to do so. Same story with here, right? So it seems that there's a pattern. There's some evidence of a slight predictability and pattern in stock prices, which cannot be denied. And we're going to use technical analysis to exploit these non-random elements, right? So this is the argument, right? I'm not saying that it's random walk or it's not random walk. I said there are two schools of thoughts, and some people think that it's random walk. Some people say it's not because of these evidences, right? So the first one was predictability and pattern, right? And the second one is behavioral finance, right? After all, human psychology and lots of biases such as overreaction and herding, these introduce some non-random elements into the market behavior. So for example, the idea is that if enough people believe, let me use another color, red. If enough people believe that this should be a resistance, and if enough people trade on that idea, when the price hit there, it's going to come back down, right? So these are some herding effects, some behavioral finance effect. And do we see them in stock price? Of course we do, but depending on the time horizons, these patterns might change. Sometimes it will not obey those patterns, right? So for example, the next time it was hitting this resistance, you thought that, okay, it should go down. But what happened? It goes up, right? So again, it seems that there's a combination of both randomness and some pattern in the stock price data. So maybe there's a middle ground. So let's look into that one. So as you may have guessed, the stock prices should be something in between, right? It is not perfectly random because after all, we know that stock prices likely are not purely random walk. And there may be some pockets of predictability or temporary trends, as the data suggests. But at the same time, market efficiency is going to make those deviations very hard to exploit, right? Because maybe in short term there are some deviations they can exploit, but very soon so many people are going to trade on those things, and those are going to be arbitraged out. So for long-term investors, a random walk model is a reasonable approximation. So we're going to say that, okay, in the long run, so probably stock price is random walk, right? And for that reason, the benchmark that we're looking for is going to be a naive forecaster. Remember, what was a naive forecaster? It's a special case of random walk with no drift and no random shocks because, frankly, we don't know those shocks, right? So an A forecaster is something like this. If the stock price today is $100, the forecast for tomorrow is also $100. And in this course, we're going to use an A forecaster as a fair benchmark for stock price prediction models. So here's a reminder of what an A forecaster is going to look like depending on your forecasting horizon, right? So here on the left, if you want to do one step ahead forecast, so this is how an A forecaster is going to look like. The black line is the stock price, and the dashed red one is one step ahead an A forecaster. So simply we are going to say that the best prediction for tomorrow's price is today's price, and it seems that it's just today, the black line which is shifted one step forward, right? So these are the predictions. And if you want to do multi-step horizon or multi-horizon forecast, this is going to be our, let's say, an A forecaster. Remember this red one. Actually, let me use the right color. This red one is our A forecaster, right? So this one, look at that. Sorry. So here, whatever the price is, so this is our train set. The blue one is our train set. And you want to use that and say, okay, for the next year or so, these are daily prices. What is the price? We're going to say if you were to use an A forecaster, it's going to be the last observed price in the train set, which is this one. And so look at that. For multi-horizon forecast, because we know, because of the random nature of a stock price, those forecasts are extremely difficult, and there is not much value in doing that either. So we are not interested in doing a task like this. But this doesn't mean that we cannot entertain with one step ahead forecast, and this is what we're going to do, right? So if you want to do one step ahead forecast, now should we do univariate modeling or multivariate modeling? And can we outbid this simple benchmark that we have? Remember, this is our A forecaster, and this is going to act as a simple benchmark to be compared with all the other models that we're going to put together. Now, does univariate model work? And by work, we mean, can it outperform our simple one step ahead A forecaster, this one? And as you can see, look at that. This red dash line, as you can guess, it's hard to beat this one for one step ahead forecast. The answer is, using univariate time series forecasting, it's not impossible, but it's really hard to beat an A forecaster consistently, right? Yeah, you can, for some specific stocks, you can do some over some period of time, but in the long run and doing it consistently using univariate model is kind of difficult. And the reason is that, complex models might offer marginal gains. Again, once in a while, they can outperform the A forecaster, but the effort and the cost of this constant updating is not trivial. It's actually substantial. Remember, when you're doing one step ahead forecasting, every single day that you get new data, you have to retrain the model and make a forecast for tomorrow, right? So this cost is not trivial, and the marginal gain, sometimes it's not going to be beneficial. And even, let's say we were able, which we will by the end of the semester, we will put together some models that can outperform the A forecaster. Even if you do that, creating a trading strategy on top of that, it's a different game, right? You need to be careful about the bet sizing, transaction costs, and basically turning those forecasts, those things that we did with time series modeling, into profitable decisions. So let me give you an example for the bet sizing. Remember, let's say, let me actually write it down, side. So sometimes we get the side of the trade, let's say 80% of the time correctly. So you have a trading system that can win, so we call it the win rate. It can win 80% of the time, but you get the size wrong, right? What does that mean? So it means that, let's say you win 80% of the time and you lose 20% of the time, but this loss, the size of these losses is more than the gain of these basically wins, right? So overall your portfolio is going to lose. So the winning rate is necessarily not the right metric when it comes to trading strategy. You have to look at the overall P&L, profit and loss of the portfolio. Again, when you take into account the transaction costs, it's sometimes it's going to make it even worse. Now, that was a univariate. How about multivariate? Can we outbid the A forecast more consistently using the multivariate modeling? The answer is yes, but it comes with some caveats. So how can a multivariate model help in terms of outperforming a one step ahead naive forecaster consistently, right? And the answer is it does it with two things, right? First using alternative data, and second by feature engineering. I would say feature engineering is key. It's really important when it comes to multivariate models. The success of these models typically depend on identifying and extracting strong and predictive features from the diverse data, right? So remember, in univariate, there's only one variable, and that's the time series itself. But in multivariate model, you have to collect more information, more information about the variables. Sometimes you need to engineer some features. So for example, you can have technical indicators, technical analysis indicators. You can have macro variables. You can have financial ratios, variables, and etc. etc. So it can be hundreds of these variables. And on top of that, you can use alternative data to create some signals, right? So for alternative data, I mean, for example, image, text, videos, and things like that. So for example, your algorithm can listen to conference calls and create real-time live trading signals, right? Get a sentiment from the conference calls. Or you can process satellite videos and images to get a sense, and by looking at the parking lots, let's say for in Apple Store or Walmart or something like that, to get a sense of real-time demand, at least a forecast for demand for that company, right? So we call these things nowcasting as well. So basically, by leveraging these things, the multivariate model can typically outperform univariate model when it comes to doing one step ahead forecast. But this comes at a cost, right? Because we know that the multivariate models are more complex, and it brings some challenges when it comes to accessibility. It's not accessible to retail investor, for example, right? Not all the retail investor has necessarily access to the alternative data. Well, you have to purchase them, if anything, right? And then building and maintaining these models is typically computationally more demanding. And remember, this is a one step ahead forecast. So this means that, for example, if you're using a daily stock data, every day you need to update all those features. Now, let's say you had hundreds of those features. You have to update all of them and then retrain the model and then basically make a forecast for the next period. Now, let's say, what if this is not daily data? What if this is hourly data? What if this is the lower frequency data or higher frequency data, right? So as you can see, it's getting more and more complex and computationally expensive for retail investors to do that consistently. And even if we do that, still the trading strategy is something challenging, right? It remains complex due to market efficiency and transaction cost, just like univariate modeling. So overall, what we can say is that beating Wall Street and outperforming the naive one step ahead forecaster is not impossible, but it's very complex and difficult. And sometimes it's not worth for the retail investor to spend time and do that, at least without having access to the right resources. So what does that mean? Does it mean that our crystal ball is broken? Absolutely not. This simply means that you should be careful on how, where, and when to use your time series forecasting crystal ball, depending on the nature of your time series. So while predicting stock prices can be challenging due to their random nature, don't let this discourage you. By the end of this course, you will have gained a solid understanding of time series forecasting that you can apply to various fields, including demand forecasting, marketing, sales, weather, healthcare, you name it. My hope is that you will become so familiar with these concepts that you will instinctively know which model might work best and what to expect in terms of predictability when you face new time series data. So buckle up and enjoy the learning. This concludes our module number 1, Demystifying Time Series Data and Modeling. In the next module, we will be setting up our deep forecasting environment and do some time series basic operations in Python. Until the next one, take care. If you're looking to stay updated with the latest versions of the course's materials, please make sure to follow my GitHub and remember to refresh your repositories periodically. If you find yourself needing a bit more background in econometrics, machine learning, or deep learning, check out my other YouTube videos for additional insights. And for all the latest news and quick updates, don't forget to follow me on Twitter. Thanks for joining me, and let's keep learning together.